Okay, hi everyone. So today we are having our second module of the Global Professional Fellowship in Green Impact and System Integration. And today our module will be on advanced material science and industrial auditing. So this module, as usual, so it's being organized by the Global Ambassadors of Sustainability jointly with the Global Green Chamber of Commerce and the Green University Network at the Kingdom of Saudi Arabia. So now I'm inviting Mr. CEO, the Global Green Chamber of Commerce, opening remarks.
Thank you, Dr. Bassam, and welcome everyone. We're so excited to have you. We're honored to be joined by an outstanding panel of international experts represented by Turkey, Egypt, and Malaysia. So together they will provide, as always, unique perspectives. We're looking at research, engineering, advanced manufacturing, as well as sustainable materials. And that will really show how innovation is transforming industries around the world. If you didn't get a chance to start last week with Module 1, we encourage you to go back and watch that. We're just getting started. This is the second module, and as you can see, this fellowship is really intentionally designed to build week by week. So we began with technology and commercialization. Then we move into that digital and community systems, and we conclude with governance and leadership. So again, each module builds upon another piece of the system thinking that we need to lead sustainable transformation. And so again, we encourage you to go back and watch the prior one. This week's theme. So by the end of today's session, you should see how measuring environmental impact as well as developing next generation materials and rethinking industrial systems design really do all come together to shape sustainable engineering. And we have some key takeaways that you're going to learn. So as you listen, so I really encourage you to think about how these 4 ideas are going to be implemented. So first, measuring environmental impact through data, and then rethinking those materials that we use. Third, designing circularity rather than just waste. And then finally, let's recognize that innovation as well as sustainability are becoming true inseparable drivers for that long-term success. And as always, we want to learn and start taking action. That's why we're here. So look at what actions you're going to impact. So consider how you evaluate those environmental impacts very early on. Explore those renewable materials, incorporate that circular thinking into your own work, and apply innovative engineering solutions that both make sure that you're reducing carbon emissions as well as resource use. So one of our favorite times coming into this introduction, so before we begin, let's just stop and take a brief moment of reflection. We're going to pause in recognition of those in our audience as well as beyond, those who are affected by conflict, disasters, and hardships around the world, while also reflecting on the values that guide our fellowship, which are kindness, strength, peace, love, and hope. So let's take one breath of silence together. And we want to extend that love, strength, and peace to our speakers today and give them strength in guiding us on our journeys in creating a more sustainable as well as kinder world. And I'm going to pass it over to Hajra, who helps us with our friendly reminders. And as we head into this, I also want to just give a huge shout out to our collective team. Hajra, who is always here with us, Jane, who puts together our materials behind the scenes, as well as we have Mila and Angelina, who will be asking for questions today. So if you're in our audience live, say hello to both Mila and Angelina if you have not already. And Hajra.
Thank you so much, Michelle. Hi, everyone. Thank you so much for joining us today. We encourage your participation as always for your engagement. Please share your thoughts, reactions, and insights as our speakers give their presentations. Tell us where you're joining us from today. And then feel free to ask all questions as the speakers give their presentations. Make sure to also put the speakers' names in front of the questions, just so that if we don't get to the questions in the Q&A session, our speakers can go back and answer those questions for you. And this is an open, inclusive, and uplifting dialogue, and we always appreciate all of your insights and your questions that come in. And we also have new reflections on this program, so please share like any thoughts, reflections you have as we kind of go through this program. As we go through this program, let us know any feedback that you have for us as well, and we will take everything into consideration. Thank you so much, everyone, and I'm going to pass it back to Michelle.
Thank you. And I want to just give a huge shout out to Dr. Wissam, who has brought us all together here today. And it's very exciting for us to be in our second fellowship and guiding each of us on this journey, bringing together the speakers and the experts. And we would not be here without him. So I will pass it to you, Dr. Wissam.
Yeah, thank you so much, Michelle and the team for these introduction and remarks. And now we start with our first guest speaker, Dr. Samar Awad Abdul Hamid. And Dr. Samar, she is an assistant professor at MEC from Egypt. So the floor is yours, Dr. Samar, and you have 20 minutes, please.
Thank you, Dr. Utam. Are you hearing me?
Yes.
Hello, everyone. Are you hearing me well?
Yes, yes,
Yes.
Dr. We are hearing. Go
Yes,
ahead, please.
yes. Hello, everyone. My name is Samar Awad, and welcome to my presentation on engineering with a zero carbon future. This is the field of my researches. My PhD was going about material science. I am an architect and specialized in building technology. Today, we will discuss how to design and build sustainable materials for the next century. Next, please. On this slide, I outline our master plan, which relies on three main pillars: material science, measurement tools, and smart circular design to achieve our sustainability goals. So we will talk about life cycle assessment and how we can measure and analyze data about materials. Then we will talk about circular design principle. So we have a closed loop between the three process as a three pillars to make the engineering of materials. Next, please. The first pillar that we will begin with focus on fundamental science of developing uh, new planet-based biocomposite and how we accurately evaluate the environmental impact. So we will learn how to choose material, evaluate material, and measure their impact on environment. Next, please, Hagar. Here we see why we must look at material entire life cycle. We can just measure how how it is manufactured, but we must also see what happens when it's thrown down away. like if it end up in a landfill to go to get through environment picture. So when we navigate the system boundaries, notice the material life cycle from starting when we build with materials, we call it cradle to gate, and when the life cycle end of the material, cradle to grave, and through its life cycle, so we can measure and identify what happened through this way. Next, Hagar, please. Natural ones in is tricky. So when we replace standard material with natural materials, this process is tricky because natural fibers can absorb too much water or lack structure strength, meaning we just carefully mix and redesign them to function properly in the real world. So when we use fibers, we use natural materials, so we can make sure that how they absorb water and how measures the strength of these materials when we use it in a structure or we use it as an envelope of a building. And I will present an experiment that will published in an upcoming paper that I am testing it with my team in the next slide. So next, please, Howard. We optimize. We make a new material. This material shown in this slide in the real world. We create a structure interior panel that is at least 60% plant based, just as strong as traditional glass fiber panel, and achieve a net zero carbon footprint. My team and me designed this material and used the calculations software. Next, please, Hagar. By testing our chemical recipe step by step, we improve the material. Especially, we changed where we bought our fiber and how we process them. We successfully dropped the pollution score from 6.5 to just 2.2. So we consider ourselves that we success to go down with pollution um, uh, uh, 60%. Next, please. When we move to pillar two, by the way, this paper will be published soon in upcoming conference, and I will share it with you all. In the pillar two, when we move to pillar two, we will talk about specific computer model that we used and to measure how this material uh, comes successfully to zero carbon footprint or was replaced for glass fiber. We use computer modeling tools and softwares for an ecosystem. We use accurately to measure carbon pollution. Next, please. The measurement tools for ecosystem. I rely on several key tools like SAMPRO and Trabi help us to look deeply into complex chemistry. One-click life cycle assessment helps translate this into market-ready reports, and Tally lets architects see the carbon impact directly inside their 3D building. So when we use the Gabi, use life cycle assessment and Tally to make a 3D model and measure the impact of using this material and how it reduces carbon pollution. That will give us a bigger picture how we success to do this mission. Next, please. So, using this data and this ecosystem, let us make smarter choices early. We can spot the most pollution steps in the supply chain and test our ideas virtually before we commit capital or create physical waste. And you all can imagine how this process help us to make the right choices in the right time before establishing any business or starting build any building. So this is a very very important process to measure how can we create a physical model before we create a real model in the real world. Next, please. This brings us to Environmental Product Declaration, EPD. I hope you are familiar with EPDs, which are essentially standardized naturation labels for environment that show buyers exactly how a material impacts in the earth. All of us in these days are asking about how the materials that we use in our building affect our environment, our atmosphere. So EPDs help buyers to know how exactly materials impact on the earth. Next, please. And to obtain this curricular ecolabel, a product must pass a strict computer model and be verified by independent third-party experts, make it standard accuracy for sustainable procurement. And that's make us move to the third pillar. Now we are arrived to this pillar. That was circular design principle, which is entirely focused on stopping waste before even starts through proactive engineering. So in this pillar, circular design, instead of trying to figure out what to do with trash at the end of a product life, we must design this better from the beginning by treating materials so they can be easily repaired instead of completely replaced. So the concept here is to design the material from the start to can be to a product modular, not a product when I finish using it convert it to a trash. So you can easily repair an instant of completely replace. Next, and this take us to the concept of DFD. Products should be explicitly engineered so they can be taken apart easily by using the mechanical fastener like clips, screws, or special reversible glue instead of permanent. We can recycle individual parts much easier. So that's what I mean here. That we can fix our materials. We can recycle it, so we can recycle it, and that will sustainability. I am trying these days to make researches and experimental about how can I make a real product that I am using in architecture process that help in this concept. Next. When we talk about upcycling waste, here are actionable way we turn trash into treasure by substitution a raw virgin material with leftover agriculture waste, industrial ash, or recyclable polymers to build strong biocomposite components. I tried with my colleagues in chemistry chemistry engineering to do some experiment about how we can mix these materials and chemicals to make or to convert trash to a recyclable material that can we use in building. Next. That take us to the economy. The economic argument, sustainability is also highly effective business strategy. When we talk about sustainability, we talk about business. All businessmen the most important is how the cash flow, and you are talking about environment, sustainable materials, and what about money. So when we talk about sustainability, it's a high effective business strategy because it protects companies against emerging carbon taxes, insulating supply chain from resources scarcity, and allows certified green products to sell a premium. Next. And to summarize my presentation, to summarize my idea, our complete approach achieving a commercially viable zero carbon product require a seamless combination of engineering, material science, rigorous computer measurement, and smart recycling design. When we mix the three pillars, we can we can achieve our target. So next. And when we talk about the future of materials through these pillars, we will leverage artificial intelligence to invent a new materials formulation even faster. We now think about mixing new materials and with the ultimate goal of moving beyond zero carbon to build materials that actively pull carbon dioxide out the atmosphere. And next. Every material system we engineer has a ripple effect, meaning we must continually balance the economic, social, and the environment impact of our design on the surrounding system, and that we measure the impact assessment on every material that we use in our building on three stages: on the economy, the social, and the environmental impact for every material in the system of the whatever we build a building scan or build a building from scratch. So we must measure the three steps: economy, social, and the environment impact. So next. Our ultimate mission is clear. We want to execute this circular design strategy to engineer the robust zero carbon materials that will define a cleaner next century, inshallah. Thank you so much for your time and attention today. And I would now be happy to open the floor and answer any question you might have. Thank you.
Thank you so much, Dr. Samar, for this interesting presentation. So,
Sorry
yeah,
for
now,
the short, but I am traveling today. I am presenting my presentation from the bus. So I hope you hear me well and was focusing with me.
Yeah, thank you so much. Yeah, it was clear. So I think for the question, because we'll take them at last, so I think you might respond to them later. And now we move to the next speaker, Prof. Dr. Muhammad Uzun. And Prof. Dr. Uzun, he's a professor at Marmara University from Turkey. So the floor is yours, Prof. Uzun, and you have 20 minutes, please.
Thank you, Dr. Wassam and Michelle and the team, especially during this summer holiday period. Dr. Wassam, hopefully next time you can start on September. There was a big misunderstanding between us. I didn't know that I have a presentation today. Yes, I'm Muhammed Uzun from Marmara University, Istanbul, Turkey. Mainly, I did my PhD on technical textiles. Then, after last 10 years, I just started working on sustainability. Without textile or technical textile, managing the sustainability is not important, impossible, sorry. These are my main research areas, sustainability in textile and footwear materials. Both are fashion-based. Natural fibers, these days mostly I'm working on industrial hemp. Today the main topic is the industrial hemp. Then some of banana, vetiver, jute, linen, nettle. And recycling, upcycling, and byproduct, these three key words are really important, especially during the production process or after the usage of any material. We need to reuse or recycle or upcycle this type of materials. This is medical textiles, which is my PhD based on wound dressings and different artificial organs. Then physical testing of any kind of textiles, engineering design, and 3D manufacturing. Today, we will be talking on three main topics. First one is upcycling. I will be sharing some of my project which I am doing with the industrial partners. Then a case study of pufferfish leather project. This is also a really interesting topic. And industrial hemp. Before getting started, without hemp, hemp plant, any medical or industrial product is not easy to have, especially in terms of textiles. Having any sustainable product or sustainable cotton or whatever you are saying is almost impossible. Three majors which I am working with the companies, more than 10 different factories, companies, we are developing different projects. First one is waste from textile manufacturing. During manufacturing, we have lots of byproduct. I'm trying to call them as a byproduct, not the waste, because every material can be converted to anything. It means these are not waste, these are byproduct of X. Then post-consumer textile waste management. I will be sharing some projects on that topic as well. And finally, oil-based polyester, polyamide, polypropylene, then cotton. Compare these two type of fibers. Now we are trying to get some bast fiber-based textile fibers. What they are: flax, hemp, jute. This type of structures can be converted conventional textiles. It means daily life textiles. I think I have 6 of projects here. These are all published in high impact factor journals. First one is lanolin based, some projects. Whatever you see in here, minimum we have 2 masters and 3 published papers on this project. Lanolin used as a cream on screen cream, but now it is a byproduct of wool production. What we have done, we get this byproduct wool wax, then converted into wound dressing with nanotechnology, nanofiber, nano electro spinning structures. Then sisal. Then another project on the chicken feather. With chicken feather, we are consuming lots of chickens, but the leftover, that feather, is almost similar quality of the wool, especially softer than wool. What we have done, we developed some t-shirt with this chicken feather. You can see online. Then propolis, again, you can see 3D structure we developed with propolis. You know that during that bee getting honey, there is between some byproduct. It called propolis. That propolis is really good for healing, enhancing the healing process. Another one is ulva lactuca for agrotextiles. These are directly developed by the companies and university between us. Another project on vetiver. This is Asian-based plant. What we are trying to do, we are developing new non-woven structures to use this type of bast fiber structures. Costume recycling, fashion to fashion, we have 2-3 projects on this, especially for this type of specific area when we are collecting their product, converting into new product. Look, Mr. Wassam, I think yesterday I sent you some PowerPoint. In that one we have extra pictures anyway for now. This is company called Waikiki. What we do with them, making this zipper or bottom much more sustainable. We are using different coating methods to having this material or removable zippers. These are really a key issue for recycling of textile materials. Whoever want to recycle this, the removing this button is always key issue for us. The removable button or zippers we developed with the Waikiki company. This is footwear stuff. You can see 3 projects in this slide. What we have done, we are using new materials to use on behalf of genuine leather. Leather is always better, but we need some extra new materials to show them plant-based leather, especially this cork leather from Portuguese. We have done really nice work on this. Now we are working 2 different companies. They are trying to use this cork leather, especially for vegan leather, we can say, and some different footwear things with hemp. And this is also another project which last 3 years we are working on it with European Union funded project. What we do, we are collecting puffer fish. I think you know about the puffer fish. Puffer fish is a invasive species. It is not very nice, little bit cute animal, but it kills all kind of local fishes, especially Mediterranean area. What we have done, textile, I mean fashion. Fashion can kill everything. On the top of the invasive species is the fashion. This is not eatable. We cannot eat this. It means we need to get some financial something for this. What we have done, we have collected around 10,000 fishes. We get some leather out of this fish. We tested this compared with the conventional leather. After this comparison, we had really nice leather. What we have done from those leathers, we have developed different type of shoes, lady shoes, football shoes. This is one of the project which we get the innovation award on this. I think I removed that publication. You can get all detail on the papers. We have also tried different natural dyeing to get different colors. You can see from this side. This is one of the important projects so far I have done. Then hemp. I'm calling as a rehemp. In Turkey, especially, not only Turkey, most of the places, the hemp is forbidden. After sometimes last 9 years before, our president said the growing hemp is legal in Turkey now for industrial usage. It means industrial hemp, not the marijuana hemp. This is one of our main target to having sustainable raw material. The main road map of this industrial hemp, First, we get legal permission from our government and develop local seed varieties. You cannot use international any kind of seeds, hemp seed, I mean. We develop our local seed varieties. Then we have done many different projects, over 35 different projects to showing that hemp is fine to use daily life textiles as well as technical textiles. These are the steps so far we are following the recent history of Turkish cannabis or hemp. Some people do not understand what is hemp, mostly known as a cannabis, but for us, cannabis means medical hemp. Hemp is industrial hemp. In 2016, first we have tried different local varieties of seed, hemp seed. Then we get permission. Then we just start growing hemp. After 3 years, we decided to grow our Turkish seed in different countries like Uzbekistan. I managed many different hemp organizations over there, and Pakistan, different universities and different associations. We grew some uh, project together. Then we developed Anatolian hemp. What is this? This is almost 4 meters plant. You can clean your land with hemp, not only the fiber. Actually, plant itself is pure sustainable product and fiber as well. We had many different group meetings. What we have done from seeds, we get some cooking oil, different composites, non-woven structures, and again, different areas, different production lines we try to develop. Now we are at the phase of CBD. Now in Turkey, CBD also, we can develop some CBD-based product. This is from Europe. As you can see, I'm not sure if you know any German. Even in Berlin, they are saying that if you vote me, then I will be helping you grow to hemp. Hemp is such an important topic for Europe, but for us, now it is just started. These are, let's say we have 2+2 different varieties of Turkish hemp right now. It is in Europe, it is almost 75 different hemp varieties. Europe is good in terms of having different type of hemp seed, but in Turkey, for now, we have four local seeds. From first picture, we get the seeds, then plant, then that stalk, from stalk to fiber, from those fibers, what kind of product we can do. That was my main target so far. These are all of my products, from bio-based plastic or paper or any military-based clothing. So far, so good. I can say Turkish hemp. These are hemp seed hearts. These are hemp seeds oil. We have tried many different food material with this seed. This was my main aim, to having proper fiber. It is not easy. It is not like cotton. Cotton, when it grow, cotton is just fiber. But in this hemp stalk, we need to convert it into this fiber structure. It takes time to having R&D part, but at the end we had proper hemp fibers. Then we have grown different seeds in different areas in Turkey. Turkey is little bit in terms of weather. You can have everything. In Black Sea area you can grow, but Mediterranean Sea area. What we have done now in all around the Turkey, we grow hemp in different R&D projects. These are different stages, different trials. Then we had another 2 master thesis on this, what kind of protective clothes we can develop with this local hemp. These are the results of those master thesis. It is really useful, especially for agro textiles, keeping the water, keeping the Water itself, it is really helpful. That moisture is always important to growing any kind of plant. Keeping the moisture for us, having this that middle picture, we had some non-woven hemp structures. We used them to grow different plants. In terms of building materials, again, this had too many insulation, isolation properties for us. We use in-house methods. We grow, let's say, tomato. We have done stress-free soaks with those fibers. Again, we get colored with the natural, sustainable dyeing materials. We have done different ropes to grow mussel farming. This is another awards we get from composites. So far, as I said, more than 35 projects I lead for hemp business from zero to final product. I'm happy actually. Last 8 to 9 years, from zero, I mean no seed, but now we have enough seed, enough area to grow hemp, and we have enough attraction from the people that why hemp is sustainable. I'm really happy. At the beginning we faced some problem, especially working on hemp is not easy task, but so far so good. In terms of sustainability, without hemp it is almost impossible. Thank you, Dr. Wassam. I wanted to show some videos. Actually, we have really nice videos of these projects. Next time.
Well, thank you so much for this interesting and lighting ideas, practical practices on sustainability, and from the business aspect as well. So now we move to the third guest speaker, Prof. Dr. Muhammad Fazil Arshad. And Prof. Fazil, he is the director of the Institute for Infrastructure Engineering and Sustainable Management from the UITM in Malaysia. So the floor is yours, Prof. Fazil. Prof. Fazil, can you hear us?
Yeah, okay. Assalamualaikum, good morning, good afternoon, good evening, and good night to everyone all around the world. First of all, I would like to say thank you very much to Dr. Wissam, to Michelle, and to Hajar for arranging this talk. And on behalf of Institute for Infrastructure Engineering and Sustainable Management in UITM Malaysia, we would like to say thank you very much for inviting me as a speaker in this lovely afternoon, I believe. So in today's presentation, I would like to share one of the innovations that have been carried out by the construction industry in order to support the initiative of sustainable program in the world. So today my presentation's title is The Future of Concrete is Smarter, Not Just More. So this is the work that I've been carried out throughout my studies, even from my PhD until today. I've keep on doing a lot of research on this matter. I would like to say congratulations to our first and second speaker who are doing a lot of work on the sustainable and be with us today. And thank you for the knowledge sharing to all of us in these lovely days. So as a start, I would like to share some of the biggest problem in concrete industry. Just for information, concrete is the second biggest material being used in the construction industry after water. Okay, normally in construction industry nowadays, we are focusing on concrete. We are also having steels, and then we also have timber as the main materials that have been used in the construction industry. So in order to produce the concrete, the main materials that required in producing a concrete is a cement. Cement acting as a binder to bind all the aggregates and then to have a solid material that we call it a concrete. Okay, so in order to produce a cement, we have to take the raw material, which is from the nature. The main material in the cement is the calcium carbonate. Okay, and then the calcium carbonate has to go through a specific technical process where the calcium carbonate has to be calcined up to 1200 degrees Celsius. During the calcination process, the cement, the calcium carbonate will be release will be release a carbon dioxide. Okay, so for every 1 ton of cement produced, okay, it will produce about 0.8 to 0.9 ton of carbon dioxide. Okay, some other researchers state that the amount of carbon dioxide produced from 1 ton of cement is 1 ton as well. So it's 1 to 1 ratio. So cement industry have been blamed as one of the biggest emission problems, CO2 emissions problem, where it's contribute about 7 to 8% of the CO2 emissions all around the world. So as to take a responsible on the problems that have been occurred during the processing of cement, the cement industry has come out with an initiative that they called it green cement. Okay, so the green cement pillars, okay, it is based uh, on the initiative of Carbon Captures Utilizations and Storage Program, okay, CCUS. We all know that around the world nowadays, when we're talking about the CO2 emission problems, the CCUS program have been mentioned and has been uh, taken as one of the initiative to reduce the impact of carbon dioxide to the environment. Okay, so due to this issue, one of the way that being used by the cement industry is by introducing a supplementary cementitious material. And this supplementary cementitious material was designed, was produced by utilizing the industrial byproduct and also the agriculture waste. Okay, just now we can hear from our second speaker state that he has been doing a lot of research using the byproducts and also from the agriculture waste in producing a lot of material, but I'm just focusing how to utilize the materials in producing a green cement. Okay, normally in a normal concrete, when we are in a normal cement, sorry, in a normal cement, we are having three calcium silicate and two calcium silicate, where these three calcium and three calcium silicate, when it's react with water, it will produce a calcium silicate hydrate gel. And this calcium silicate hydrate gel is the main materials that bind the aggregate in the concrete. But instead of that, the reactions also are producing a calcium hydroxide. Since the amount of calcium is quite high, which is about 60%, but the compound of silica and alumina inside the raw materials of cement is only about 40%. So mean to say that it will have an extra of calcium which react with water and forming a calcium hydroxide. Okay, so this calcium hydroxide actually is not a good binder and is not a strong structures of silica that create another problems in the concrete structures, okay, in the concrete matrix. So in order to reduce the impact of calcium hydroxide, okay, so the industry are introducing a supplementary cementitious material that having a pozzolanic properties. Okay, what we call as a pozzolanic properties or pozzolanic reaction, by adding a materials that containing silica and alumina, okay, the silica and alumina can react with the calcium hydroxide to produce a secondary calcium silicate hydrate formations. So it will utilize the calcium hydroxide to form more calcium silicate hydrate. Okay, the benefit of having more calcium silicate hydrate, definitely the concrete strength will be increased. It will reduce the permeability because the lack of calcium hydroxide, which have been formed into the stronger crystal, which called it calcium silicate hydrate, definitely it will fill in the void and reduce the permeability of concrete. Instead of that, the material also identified have been successfully lower the hydration and also lower the carbon footprint issues. So this is the first mechanism on how the pozzolanic materials or supplementary cementitious material react. The first one is the finest particle of the calcium of the pozzolanic materials will fill in the voids. Okay, so it will reduce the porosity. On the mechanical part, okay, the fine particle will form a lot of more calcium silicate hydrate crystals, and the calcium silicate hydrate crystal are giving more strength even at 1 day of the concrete age. And on the third mechanism, it's forming a secondary hydration process where the extra of calcium hydroxide, okay, have been reactive, okay, to produce more calcium silicate hydrate. So as I've been mentioned before, by having more calcium silicate hydrate, we are going to have a more high continuous strength gain. We are reducing the calcium hydroxide crystal. We are also improve the sulfate resistance and reduce the permeability of concrete as well. So as the upcycling waste into structure asset, normally the most successful material in the world nowadays on the supplementary cementitious material is the fly ash, is the GGBS, and is the silica fume. It is an industrial byproduct, but me and my team in ISM, okay, we are keep on doing a research to look more materials uh, that having the pozzolanic properties, okay, instead of fly ash, GGBS, and silica fume. Okay, we have successfully identified more from it from the industry. Is a byproduct such as waste paper slash ash. We also find the microsilica, the mining sand waste. Okay, even we also have the foundry sand particles also can be used as the cementitious materials. Okay, supplementary cementitious material. Instead of that, we also identify other materials such as metakaolin, and we also find rice husk ash as the one of the materials agricultural waste that we can use in producing the supplementary cementitious material. So this is some of the summary on how the material have been improved the properties of concrete, which refer to filler effect, early strength, long-term strength, and carbon dioxide reduction issues. Okay, so from all this material, we can found that most of the material are producing a good an excellent value instead of silica fume. Okay, this silica fume is the waste from the alumina industries. Okay, but somehow it is still improve the early strength of concrete. But we're talking about the filler effect, it's not very good. Even if you're talking about the carbon dioxide reduction also are low, it's not because of the utilizations of silica fume are reducing the CO2 gases, but the process of getting the silica fume itself are increasing the CO2 amount in the environment. When talking about the strength, okay, which is the main criteria in concrete, we can see that the utilizations of fly ash, silica fume, and metakaolin has increased the compression strength of concrete as compared to ordinary Portland cement. But we have to bear in mind at the early age, the utilizations of fly ash, GGBS, and metakaolin are not really perform good as OPC, but it will improve the long-term strength. So, as the end of my presentations, I would like to say something about the utilizations of byproduct or agriculture waste in the cement industry is possible. Even nowadays, we already have a green cement logo or products in the industry. You can identify the green cement by looking at the color of the packaging. If the packaging of cement in a green colors, so it's represent the cement as a green cement. Okay, so for ordinary Portland cement, it is in a blue color. All right, so you can differentiate it in Malaysia. Now, last time the green cement is expensive more than the ordinary Portland cement, but nowadays, Alhamdulillah, in Malaysia, the green cement, okay, has a price comparable to the ordinary Portland cement. Even some company are selling the green cement cheaper than the ordinary Portland cement. Why? Because they are using a waste material or byproduct material to produce another type of ordinary of Portland cement. Okay, so my last word on my presentations: the futures of concrete is no longer producing more cement, but producing smarter cement. So with that word, I end up my presentations. Thank you very much, and assalamu alaikum. Back to you, Prof. Dr. Wissam.
Yeah, thank you so much, Professor, for this interesting presentation. And now I'm handing over the session to Michelle and the team to moderate the Q&A session.
Thank you, Dr. Wassam, and thank you to all of our speakers. I know connectivity issues may be a problem right now for Dr. Samar, but hopefully she'll be back in. And we will start with Dr. Uzun. And we have, and I just want to say thank you to our audience for sending in some of the most thoughtful, informed questions. They just become more and more so each and every week. So we will start, we'll start with the first question from Fazail Afridi, and he is from Karachi, Pakistan. And the first question we have for you, Dr. Uzun, which is, which bio-recycled fibers, lyocell, hemp, chemically recycled cotton, can scale, and what are their durability, dyeability, and trade-offs? And if we can, a minute or two, somewhere in there.
Thank you. Very technical questions. You mean regenerated fibers compared to hemp? Which one is easy to biodegradable? Is it the question?
I'm sorry, ask that again?
Michelle.
Yes.
We are asking regenerated fibers is apple. What was the question?
So the question is, which bio-recycled fibers, so lyocell, hemp, chemically recycled cotton, can scale, and what are their durability, dyeability, and cost trade-offs? I know it's a complex question, but yeah.
I think it is better to ask. This is very technical question. Actually, it has three questions in one. I think it is better to let him text to me.
Okay, and so just as far as I think a quick question might be: are biodegradable and recycled fibers inherently weaker than the standard products?
No. Compared with recycled fibers, there is no mechanical difference between virgin fibers compared to any recycled fibers. Especially oil-based, there is no difference between these two. But for recycling of any cellulose-based fibers, if it is regenerated, then it is fine. But depends on mechanical or chemical recycling. Depends on that. Chemically recycled fibers has some weak point compared to virgin one. We can say that for now.
Okay, wonderful. Thank you so much. And I know some of these questions are really in depth. So thank you for just sharing with me that we can pivot. And thank you for answering that online. So always, if you're asking questions and we don't get to them, just always keep in mind that our speakers will be looking for those online as well. So we will go to you, Dr. Fadil. And we have a question from Dr. Indira Bunik from Switzerland. And she asks, what are the most common blind spots industries have when measuring their carbon footprint?
Okay, thank you for the question. Okay, we are talking about the most common blind spot industries when measuring the carbon footprint is that there is no direct equipment that we can calculate the amount of carbon dioxide produced from a materials to a materials. Okay, so instead of just calculating the amount of carbon dioxide produced from the industry when during the production process, we also have to taking into account on how much carbon dioxide have been released or produced by the other supporting programs in order to produce the products, such as the transportation costs, the utilizations of energy, okay, the heat, okay, that produced by the machineries. So this become a challenge actually by the evaluators of the carbon footprint account. Okay, we're talking about ESG, especially nowadays. People are talking about ESG. They are requiring the numbers of carbon footprint amount to be presented, and most of the personnel, okay, or most of the industry don't have that capability in order to understand and to calculate the real carbon footprints numbers being produced or being reduced. Okay, so I do believe that we have to be ready, okay, or we have to be to have some specific or simple tools, okay, in order to calculate the carbon dioxide emissions, and with that we can translate it into the numbers of carbon footprint by industry. Okay, and we have to bear in mind the values of carbon footprint values differ from industries to another industries. Okay, I hope I'm answering the question.
Yes, thank you so much. I really appreciate that. And I think that we have Dr. Sammer here. And we have a question. Dr. Sammer, can you hear us? You're on mute if you can hear us. Dr. Sammer. If not, I'll jump back over to Professor Dr. Uzun. And we have a question from Dr. Raza Shah. And they ask, what are the steps to begin developing sustainable material production? And if you can answer this as well, how do you see the industry growing on a global scale, particularly in Pakistan?
First step for developing a sustainable material, we just need to some 7 key points of looking at that material. Which sector he's asking is in terms of textiles. In terms of textiles, compared to Turkey, Bangladesh, Pakistan, Egypt, we are far away from to become sustainable way. The major thing is the having some quality product that we need to, in terms of, as Dr. Samar uh, said about financial things, the sustainability directly related to finance. For financial sustainability, we need to develop, we need to produce. For material minded sustainability, we need to stop producing and checking whatever we are doing. In that case, it is not easy to have in textile, especially for fashion based textiles, sustainability not easy for now. For Pakistan, for Bangladesh, as I said, for textile based countries.
Thank you. Thank you so much. And I think we've lost Dr. Sammer. Hopefully she'll be back, but we will go to you, Professor Dr. Fadil. And we have a question from Abel Jimenez. And Abel asks, we have, will this stronger cement result in less material needed for construction? And what tests or research have been done on this particular question?
Okay. From Abel Jimenez, right?
Yes.
Okay. Thank you, Mr. Abel, for the questions. Okay, when talking about the materials that been used, okay, I would like to relate your question with the question asked by the Mr. Faisal Afridi. He has also been asking about the potential of utilizing other alternative materials such as geopolymer, carbonated silicates, and replacement Portland cement. Uh, and then he's also asking about the self-healing. Okay, and when you're talking about doing any testing on it, yes. Okay, in my Center of Excellence, we are responsible and we are doing a lot of research, okay, in order to identify the potentials of these materials. Okay, and we are successfully producing a new type of materials, a new type of cement. As what you mentioned here is a stronger cement. And we are using it in industry. Just for your information, nowadays all around the world, okay, people are already accepting the silica fume, the fly ash, and GGBS as a supplementary cementitious material. Instead of using it as a supplementary cementitious material, they are also using the materials as a replacement of cement. Up until today, the industries are successfully replacing the ordinary Portland cement by utilizing this so-called uh, silica fume, fly ash, and GGBS up to 50% replacement. And so-called they also claim that they are successfully producing a concrete, better concrete strength, even up to 80 megapascal at 28 days, and also improve the durability. We also have a standard, the British standard BSEN also have a standard, and ASTM also having their specific standard, okay, in utilizing these materials. So what I can say that the utilizations of the waste materials that have been mentioned before is already been accepted by the industries all around the world, but the scientists, the engineers are still progressively identify new type of waste material that we can utilize in producing a better concrete or a better cement. Okay, what I have mentioned before, this type of process is continuing process, and we are from day to day we successfully identify the material, and the most common material that we have to look into the chemical compositions of material to be used as a pozzolanic material is a silica and alumina, or silica itself or alumina itself. Okay, when we have a material, that containing silica and alumina at a specific uh, size, we can use the material as a replacement material to ordinary cement. Okay, so thank you.
Thank you so much, Professor. And
Michelle, sorry,
yes.
I just think that question which I could answer properly. I think I just in chat. It says lyocell and antiphilic cotton. Of course, lyocell on the top of all kind of resources now, especially commercial lyocell on the top. Maybe voluntary recycled cotton in the second, the hemp in the third place for now. But hemp is growing, but still in terms of commercially availability compared to lyocell with hemp, so far lyocell on the top of everything.
Thank
Thank you.
you, Dr. Uzun. Can you share with me? I couldn't hear the very first part. Which question were you answering? Whose question was it?
Which bio recycled fibers can scale and what are their durability, and cost trade-offs? This was the question which I couldn't understand properly. Right now I can read the question. The answer is, of course, lyocell.
Okay, perfect. Thank you for answering that question. And just one more question here. I want to take a step back because I know that we get into all of the details, and that's why we're here on this elevated conversation with this particular program. But I know that we have a great question as well, kind of big picture from Zohir Ibtasam from Morocco. And I don't know if you saw this, Dr. Uzun, but Zohir asks, can you define advanced material science as well as what do you think its importance is in modern history? I know that's kind of the big picture, but sometimes it's nice to go out and then because we've been getting into so many of the details and we always appreciate the variety of different types of questions.
For me, advanced material in the human history always there. The comparison between this advanced, technically advanced, or what we mean with advanced. Let's, yeah. In terms of internet, we are on the top of the advanced material era. But compared to what? Compared to what? That question means from first human to today, we always had some advanced material. Maybe we think that we are on the top of the human history, but we are not sure. We don't know what happened a million years back before.
Yeah, thank you. Thank you so much. And thank you, Zohir, for the question. I'm going to add the QR code up on the stage right now. So for those of you who've been with us live or you're watching it later during the recording, this is the QR code to number one, take your quiz for today to receive your certificate for this particular program. And if you complete 10 out of the 12 modules, you'll receive the second fellowship certificate as well. So hopefully you can go through and complete the code. And somebody had asked in the questions live on LinkedIn if they needed to do it immediately after this program. We always encourage it because we know that if it's front and center, we know that you'll address those questions sooner than later, but you can take it at any time afterwards. I know sometimes people have to get back to work right away, and so you're welcome to take the quiz, later in the day, tomorrow, next week. But again, sooner the better because we know we have another one coming up next week. So I know we have time for just a couple of more questions. So we will go to you, Professor Fadzil. And we have a question. Let's see. We have a question from Zuradaya Hussein, and they ask, smarter cement is good for current and future sustainable construction, but has any research been done on utilizing the recyclability of old cement from previous destroyed construction?
Okay, thank you, Ms. Juraida Hussein, for the question. It is a significant question on the issue of recyclability of old cement. Okay, before I answering the question, but I think we have to be clear on what is meant by old cement or recycled cement. Okay, so from the previous destroy constructions terms, I do believe that the old cements mentioned by Ms. Zuraida is the cement that we are extracting from the uh, destroyed concrete. Okay, or in our terms nowadays we are called it a recycle concrete. Okay, so if the question is refer to the recycled concrete extractions of cement from it, what I can say that actually the cement in the old concrete so called, or the recycled concrete is already hydrated. Okay, it's already hydrated. So if we want to utilize the hydrated cement, it's become more difficult and we get to use more energy to reactivate the the old cement as mentioned by Miss Juraida. Okay, so in order to do that, as for now, the industry are reluctant to extract the old cement from the demolished or destroyed concrete or recycled concrete, because the cost is very high. Even it will make the price of the cement become higher as the normal cement. So what they are doing nowadays, they are just using it as a recycled concrete aggregates, where the recycled concrete aggregates is more economic as compared to recycled cement. Um, that would be my answer for the question. Thank you.
Thank you so very much. Yeah, really good question too, because it's something that we work with a lot of people who are using those types of recycled material or looking to use that new resource in their businesses. So I think it's really important to cover those types of topics. And our next question is for Dr. Uzun. And we have a question from Abel Jimenez. And Abel asks, how does a country's climate affect the production and use of these materials, and can this industry take off in tropical climates like Costa Rica?
I think he means on hemp. Which material which plant? Hemp.
Yes, I believe hemp.
I believe so. Hemp we are calling as a shameless plant. It can grow wherever it is planted. It is really funny. In some part of Moscow, compared to in Antalya, and Mediterranean Sea area and Black Sea area, totally different climate, but still it can grow. It so far. But in Costa Rica, especially in that area, I think you will have better industrial hemp plant. For medical hemp, it is greenhouse production that is totally different than what I'm talking about, fiber-based hemp.
Okay, thank you. I think I heard the end of that. And again, just want to remind everybody about the QR code. Please utilize this, and we'll take one more question for Dr. Professor Fadzil. And we have the question from Faisal Afridi, and he asks how to design fully recyclable concrete with aggregate recovery and rehydration integrated with CO2 utilization and renewables, and what policy and infrastructure changes enables this closed loop system? That's a big question. So if you can try to, you can just take one part of it that you feel most comfortable asking in a timely fashion.
Okay, thank you, Mr. Faisal Afridi. First of all, I would like to say thank you very much for the questions. And from the chat room, I do found that Mr. Faisal has asking many questions. Looks that is really interested on this topic. Thank you for your interest. Okay, we're talking about the utilizations of recyclable concrete with aggregate recovery and rehydrations integrated with CO2 utilizations. Okay, there's some research have been carried out. Even me myself and my team are also doing a research on the recycled concrete aggregate. The main issue or the main problem with the recycled concrete aggregate is that most of the recycled concrete have been dumped in the same area without caring about the quality of concrete they have been done. Okay. Normally concrete we have a different grades. Okay. On the first place, if we can spread up the concrete grades, from that we can categorize we can categorize the quality of recycled concrete aggregate. Maybe we can state it as a grade 1, grade 2, or grade 3 recycled concrete aggregate. Okay, and then actually this research have been carried out. Last time I have one PhD student who are doing this research where he tries his best to come out with the standard specifications for recycled concrete aggregate grade A, grade B, and grade C. We are successful in producing the table, but until today there is no serious takers on the finding. But anyway, when talking about the utilizations of designing the concrete by using the recycled concrete aggregate, personally, I would say that maybe we can use this recycled concrete aggregate not for structures, but we are using it for non-structures materials such as the bricks, maybe the road curb, or even the drainage. Okay, what people are doing nowadays, the industry doing nowadays, they are using the same quality of aggregate, so-called the granites. Okay, the high quality of aggregate for all the type of constructions of all type of concrete. For me, this is a waste because the non-structures product not really require a high quality of aggregates. Okay, we can use the recycled concrete aggregate and at the same time we can reduce the demand of high quality aggregates. Okay, where we can use it specifically for the structures. Okay, and one thing that I want to share our experience last 2 years when we try to use the carbon dioxide gas as the curing chamber, as a curing materials for a concrete. We try using the recycled concrete aggregate, and then we are exposed the recycled concrete aggregate to the CO2 gas in the curing chamber, CO2 chamber. We do found that that process has improved the properties of recycled concrete aggregate itself. Okay, so when talking about the potentials of using the recycled concrete aggregate, I do believe that the potential is there, but the matters of either the policies of governments in our worlds want to using it or not. But in Singapore, they are already give some tax reduction to the construction industries who are using the recycled concrete aggregate in their constructions. They might get the reductions of tax, okay, up to 20% from the total cost of the constructions. So I do believe that we got to move forward. We got to give more knowledge to the peoples and to the industries to accept the ideas of recycling in recycling materials in construction industry. Okay, so
Thank you, Dr. Fadzil. I know that was a complex question, and really appreciate your answer. And I know that we are out of time for our questions, but we did get through quite a few for the two of our speakers. And I know that if you ask questions and we didn't get to it, please keep an eye out for the answers on the thread. And I want to say thank you so very much for taking time out of your busy schedules here, to our speakers, as well as those coming in live and asking all of the questions. You are part of this collective team. And I know many of you have been speakers before as well. And one thing that I will say, I know that we have such great exposure. This particular series is at least 10 times, has more 10 times the engagement rate than others on LinkedIn, and that is because each of you are really sharing it. So please do share with your colleagues, share with those who are in the industry, share with your fellow professors, those that this will appeal to and be in line with their programs. So that's how we get this out. That's how we share the information. And so we really are so grateful for that. And without further ado, I will pass it back to Dr. Wissam for our closing today. And I want to say thank you again to our collective team who have been asking and collecting all the questions on the back end. So thank you, Mila and Angelina, who are new with us, and of course, Hajra and Jane and Natasha. So thank you very much. And Dr. Wissam.
Yeah, thank you so much, Michelle and the team. And special thanks to the speakers, Dr. Samar, Prof. Fazil, and Prof. Ozon, for their interesting sharings. And I think this is today is quite interesting because we are talking about academicians, the researchers who are sharing ideas that in many cases it's transferred to a product in the market, like the cases presented by Prof. Ozon and also Prof. Fazil. And I think this is a promising ideas where I think last week when we discussed on how to bring all these research products to the commercialization stage. And I think this discussion also from the questions of the audience, this open up new opportunities for networking and also collaboration in other countries. And I think this is one of the aims of this platform, is to share knowledge and experiences which can be transferred. So again, thank you so much for the speakers, for the audience, for the engagement. And just to mention here, please, if you have any reflections on the module, can you please write that down in the comments, because we are compiling for each module a policy brief on the technical discussions and the policy and strategy implications, and we are publishing that in electronic and online magazine. And this is quite interesting because we got a lot of positive feedback on the review and readings. So this is another avenue for us to share the knowledge in a written form as well. So we are welcoming your reflections, and definitely will be also acknowledging all these reflections in the writing as well of the policy brief, plus the authors who are the speakers for this matter. So thank you so much, and we'll see you next week in the third module. I'm sorry, Prof. Ozon, we continued our series. We know a lot of people on vacation, but we want to gain the momentum for this program. And yeah, we are having a lot of positive feedback, so we wanted to continue on the momentum from the first program. So we'd love to see you again next week. So have a good time, everyone, and bye-bye. Thank you so much.
Thank you.
Thank you.
Thank
thank you,
you.
everyone.
Bye.